Okay, yeah, so y'all's is 28, this is 23 on mine though. Okay, so first thing it says, let's read the instructions, it's a big one. Graph f of x, so it wants us to graph what they give us at first. Then find the inverse and graph that and answer the questions about the inverse. So first we need to graph f of x. F of x is x minus 2 squared plus 3. So I'm going to use a table to help myself graph that one. What is the parent function for a quadratic, which is x squared? 0, 0, 1, 1, 2, 4, right? In the other direction? Negative 1, 1? Negative 2, 4. Good, so that's the parent function. Now we need to see how it moved to actually graph this original f of x. So we have x minus 2. How does that move? Right 2. And what would that do to my table values? To what? To the x, right. The right is horizontal movement. Right 2, we're adding 2 to all the x's. So now we have 0, 1, 2, 3, and 4. Okay? Also, we see a plus 3 right here, right? So what does this plus 3 do to our graph? Up 3. And what would up 3 do to my table? Add 3 to the y. That's right, good. So add 3 plus 3 plus 3 plus 3 plus 3. So now we have 7, 4, 3, 4, and 7. Okay, so we finished that, right? And we would want to graph these points, right? However, notice there's a restriction on the domain here. It says your x has to be greater than or equal to 2. So some of these points are not going to fit within the restrictions, right? Which of these points wouldn't work in the restrictions? The bottom half? Because look, it's x values, right?
0.
Right, the top half. So this 0, 7, look right here, 0. Is that x value greater than or equal to 2? No. So this point doesn't count into our function. Next, we got 1, 4, right? But is 1 greater than or equal to 2? No, so this point also doesn't work. But now 2, 3, and 4, are those x values greater than 2?
Yeah.
Yes, they are. Greater than or equal to? Yes, they are. So, right, so those are the points that we're graphing. We're going to graph 2, 3. We're going to graph 3, 4. And we're going to graph 4, 7. And so the graph just looks like this because they cut off the other half with the restriction. Okay. So then we need to graph the inverse. And how do we graph the inverse? We just take points from the table. So let's say our inverse is, call it f negative 1 of x. You flip them. So what are our points then? 3, 2, 4, 3, and 7, 4. Very good. We just took those 3 points that we had and we switched the x's and y's because that's what an inverse is. So let's graph that 3, 2, 4, 3, 7, 4. And there you go. That's what the inverse looks like. So there we go. We have graphed the original. We've graphed the inverse. Next, it wants us to answer the questions that they ask us. So it says, what is the equation for f inverse of x? So we need to find the equations. So we're going to take our original, which is y equals x minus 2 squared plus 3. And how do I use this equation to find the inverse? Switch the x and the y. So we have x equals y minus 2 squared plus 3. And now we need to solve for y. So what do? Subtract 3, which gives us? Right. Now what do we want to do? Square it. When I square it, what should I get? Just like that? Square root of x minus 3 equals y minus 2. Okay, so Omar brings a good point. So Omar's like, well, what about the positive or negative? Right? Because normally we have plus minus, right? We just did an example like that. Right, there's a restriction on the domain this time. You see how they cut half of it off, right? This time we can also see, but from our graph, is this the top half or the bottom half? Is it the positive or the negative? Only the positive is shown right there. So that's why we don't use the negative square root right here. So originally, yeah, we would have plus minus. But since our inverse graph is restricted to where only the positive half shows, we don't need to put the negative. And you don't have to write the plus sign, right, to show a positive.
Okay, if it was the other way around, you had to put the negative.
Exactly, yeah. If it was upside down, like the bottom half, then you would just have the negative sign. That's right. So, and also remember, just inverse, you switch the x's and the y's, right? So look at this. If the domain is x is greater than or equal to 2 on the original, right? That means on your inverse, the range is y is greater than or equal to 2. And notice how, look, all the y's 2 and up. All right, that's why it's positive. Okay, and then so our last step, what do we need to do? Add 2. And so my final equation is? Right, but remember, we don't use y. We're writing the inverse function, so we're going to put f negative 1x equals square root of x minus 3 plus 2. And that is the equation for the inverse of f of x. And look at this. Even if you look at this equation, you know you did it right because the transformations to the square root, it says, if you look at the equation you just got right, it's to the right 3 and up 2. And then look at your equation. Look at your graph. That's just a square root graph moved to the right 3 and up 2. Isn't it? Isn't it? And now, lastly, is the inverse of f of x a function? Why or why not? So look at the inverse, the blue. Is that a function? Yes or no? All right, Omar says yes. It is yes. Why is it a function? Yeah, why is it a function? Because it has points. There are many things that have points that aren't functions. What? How do you tell if something's a function or not? What? What line test? So on this inverse function, which one is it? Vertical line test, right. Because the inverse function f negative 1 of x passes the vertical line test. So it passes the vertical line test, okay, which means that there are no repeating x values, right? That's the whole point of the vertical line test, because you know you might just like say it passes the vertical line test, have no idea what you're talking about. The vertical line test is just used to show if x's are repeating or not. If x's were repeating, then you would have like another overlap down here somewhere, right? But because it doesn't, that means there's no repeating x's. That's what a function is. It's a one-to-one. And that's going to be the last one. Oh boy.